Good afternoon. I hope you are doing well over there. Vuyani Kingdom is my name, and I'm going to be taking you through the topic of mathematics grade 10. We are going to be doing functions. So, what I'm going to do here is just a revision for grade 10. I'm not going to give you all the full insights. In case you might need the lessons, my number is 0678908546. I'm going to repeat this: 0678908546. That's my number, so that you get the full session of mathematics. We do have a class at the episode. We'll also do offer online classes, but this one I've decided to revise functions. Just a revision for those who are writing grade 10 this November month 2025. Okay, we have linear functions. We also have quadratic functions. This one is called parabola. We also have exponential. We also have hyperbola. Right, these are the functions that we have in grade 10. Alright, we also have, if I underline a little bit, and then we say we also have as well sine function. We also have cosine function. And tan function. So 1, 2, 3, 4, 5, 6, 7, depending with time, I'm just going to do a few of them for your revision, and then I'm going to send this link to my Facebook, to my WhatsApp status. If you have my number, everywhere, wherever you can access the link, I'm going to share the link, because I'm going to post this one on YouTube. Right, so now those are the functions that we had. So I will take you through the firstly the linear function. Not too much of writing, but more of probably brief explanation. Right, this one is the one that we did in grade 9. It says y equals mx plus c. So here we can also represent it like this: f of x equals mx plus c. Right, with this one, m is the gradient. Right, and then c is the y-intercept. Y-intercept is a point where the graph cuts with axis, the y-axis. And the value of x of x equal to 0 there. Just close. So y-intercept is a point where the graph cuts the y-axis and the value of x equal to 0. So that's the y-intercept. So the y-intercept, which means it has the value of x being equal to 0 there. Right, and then we have the gradient, we have c. Now, about the m, we have the equation of m, which I'm going to plug here quick. We call it delta y over delta x, which we also call it y2 minus y1 over x2 minus x1, which we also again call it tan theta, which we also call it limit as h tend to 0 is equals to f of x plus h minus f of x all over h. So this I don't know, I'm now taking it too far, all over h. So this is your average gradient m delta y over delta x, which is still as y2 minus y1 over x2 minus x1, which is still the same as tan theta, which is also the limit as h tend to 0 is equals to f of x plus h minus f of x all over h. But this one probably for a grade 10 is just going to be too much. You may not understand. This you need to understand. We will talk about it when we are doing trigonometry. Apparently we are doing functions. We will talk about it, how these are related. And then in the future, when you are going to grade 11, I also introduce this one and see how are they related. And then in grade 12, we talk about all being related. Right. So now this is all about a linear function. But then let's take a look at how do we sketch those. Now we know what is a linear function. Let's see how do we sketch a linear function. Sketching a linear function, there are three methods. You can use tape method. Something like this. X, Y. And then the idea of the tape method, remember, f of x equals mx plus c. Right. The values of x, you design them yourself, and the theory of the values of x says there must be at least a number on the other side of 0, of which we have 1 here, we have minus 1 here. I did not say exactly it must be minus 1, 0, then 1. You can start with the minus 2, you can start with the minus 20, depending on the paper that you are actually writing on. If your paper allows you to start with minus 1 million, you can start with minus 1 million. I don't know how large is the graph that you're going to draw. So probably at least there must be a number or numbers on the other side of 0 and the other side. So now we have actually put the values there. Now you can now substitute these values into the equation to find the corresponding y values, and then after that you go and plot according to what you are getting right here on the corresponding x and y values, and then you join. And then after joining, suppose this is your linear function. After joining, you tell us this is f of x is equals to mx plus c, depending with the actual equation that you are given. This one is the formula. I think I've explained how to sketch a linear function using the tuple method. Let's move on. We can also sketch the linear function using the dual intercept. Dual intercept. Dual intercept method. This one is one kind of a method that I will always advise somebody to use, because most often that is the one that is used in FET, and that is the one that is in the memo of grade 12. I know I'm talking to grade 10 here, I understand, but this one is very important. So this one, let y equals 0, then solve for x, and then let x equals 0, then solve for y. So this is what we do in dual intercept method. Given the f of x, let me write it here, f of x is equals to mx plus c. Right, if I am to let y equals 0, then I will have 0, or f of 0 is equals to mx plus c. Then I solve for x, right? And then I let x equal, or let x equal 0. Then I will have f of x equals m times 0 plus c. Then I solve for y. I think that one is understandable. But then after that, I now have 2 points here that I need, of which those are x and y intercepts. So suppose it's x 0, this is the y intercept, this is the x intercept, and then 0 y, which is the y intercept. Now you have these 2 points. Now you can sketch your graph, x, y, x, and then there we go, your graph. Your graph may be positive, may be negative, depending, with what they're given in the equation. So, right, that is that. I think I've explained about dual intercept method. Let's talk about the gradient method. That one is one kind of another idea that is very easy. Remember, M method. I'll just write M method. Have you noticed that M is equal to delta y over delta x? So what I do, maybe I'm here, I'll say 1, 2. If the gradient, okay, let me say, suppose y equals to 2 over 3 x plus 3, whatever. Let me say minus 3, because I'm already here. I'm here at minus 3. So I'll go 1, 2y times minus 1, 0, minus 2 minus 1. Yes, so which means I'm now in minus 1. Right? Minus 1. And then I'll also go how many times? I set it here. Then 1, 2, 3. And then I'm there. And then I go again 1, 2, and then I go 1, 2, 3. I'm there. So now I join together. That is what we actually call the gradient method. This one they don't normally ask it in grade 10, but this is the one. This is for grade 9. Right. Doesn't matter that much, this one. What matters? Equation of a linear function. Equation of a linear function. How do we deal with that? We need to know. Let's see what we can do. We know that f of x equals mx. Let's see. Right. What if you are given the y-intercept and one other point? So you are given the y-intercept and one other point. What you are going to do here, you are going to substitute the y-intercept, the value of c, which is the y-intercept. You put it right there, and then now you are, suppose it's y-intercept is actually 0, 3. So now you have f of x equals mx plus 3 responding to the y-intercept. But then you need another 0.24 general. Now you are going to substitute this point into this whole thing. Right, how do we do that? This is y, so we can say 4 equals well, we don't know the value of m. Okay, we can actually equals to m times 2. We can say 2m. M times 2. Remember, m times x plus 3. Now, taking the other one, this one the other side, you have 4 minus 3 equals 2m. So you have 1 equals 2m. Divide by 1. Divide by 2. Divide by 2. You have m equals 1 over 2. But they say to find the equation. So now you can come and plant this 1 over 2 right there where we started. F of x equals, now it's 1 over 2, which is m, x plus 3 there. Now you have solved for your equation. That is the first way. But then generally, quickly, let me give you the insight before I even erase this part. The insight here is that the equation is going to clarify to you in which form or in which manner do they want your answer to look like. Remember, your answer may look like 1 over 2x plus 3. This is still the same answer. So they will specify that if determine the equation of a linear function blah 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 with these points, and then in the form of f of x equals to mx plus c or y equals to mx plus c. So it depends what they say. If they say y equals to mx plus c, this is going to be your answer. If they say in the form of f of x is equals to mx plus c, this is going to be your answer. So this is very important because it's 1 mark for this thing. 1 mark for it. If they say it in the form of f of x and then you put this one, you lose a mark. Let me move on. You might be given 2 points, 2 random points, 2 points. Randomly, no x-intercept, no whatsoever. No y-intercept. Alright. What do we do there? We know. Sorry. F of x equals mx plus c. This is one thing that you always have to remember. Given 2, 4 and 3, 5. Determine the equation. I'm just giving general example. Now there are 2 methods here. You can deal with that simultaneously, or you can deal with finding the gradient first. Let's find the gradient. Simultaneously, you will have to find out how it works by yourself. Right, gradient, this being our 2 and this being our 1, we'll have y2 minus y1, which is 5 minus 4, divided by 3 minus 2. What is going to be our gradient? 1 over 1. So our gradient is 1. So we know that the m is equal to 1. So we can say f of x equals x plus c, because that's the 1x here. X plus c. Right, take any of these 2 points, plug it here, get the answer. We can take that and consider that the 4 equals 2 plus c. Solve for c. Solve for c. So 4 minus 2, sorry. 4 minus 2 equals c. So 2 equals c. Now you have 2 equals c. Plug it back there. Now you know that is f of x equals x plus 2. It ends there. That's your equation. If you try plugging this one here, you'll get the same answer. Try it. Right. Those are two methods of dealing with solving the equation of a linear function. Right. In the next few minutes, let's talk about parabola. Parabola. Sorry. All right. This one. It's another also nice equation. F of x. What is the equation of a parabola, by the way? A x squared plus q. Yeah. Now this one changes a little bit. They've changed. Ax squared plus q. Now, q. Let's start with a. Determines the concavity of your parabola. I will show you how. And then q. This is grade 10. All right, let me call q the y-intercept. Y-intercept. This one in grade 10 is always your TP. Only in grade 10, this is your TP. Right? So that A, this one I've explained. Let's explain further about A. If A, let's start with the greater than 0, it will be concave up. If A is less than 0, it will be concave down. So this one is like this, this one is like this. Right? At some point, quickly before I even start talking much about the parabola, we now know that the shapes of a parabola are things like this, right? Mind you, such a parabola like this one here, you see, it does not have x-intercepts. Oh, this one, it does not have x-intercepts. So don't find yourself wasting time on such parabolas. Actually, as we are going to talk about the parabola, you will find out that, okay, sometimes you don't have to waste time trying to find x-intercept where they don't exist. Right. So let's check how does this whole thing work. You find the link, you actually notice that these things, they are linking from one function to the next. We're talking about the linear function. Now we're going to the parabola, but you will find some kind of relationship in another way. How do we sketch that one? I hate this thing that like we are always told that like check the concavity of a graph. You already know that if A is greater than 0, then it's concave up. So why do we have to list that step like check the concavity? No, that one is just a waste of time. You already know that if A is less than 0 and then it's concave down. So it's a waste of time to say like check the concavity. Let's go straight to the point. All right, find the intercept. The intercept. Intercept. No. Right. Y int. This one, let x equals 0. This is exactly what we did earlier in the linear function. And then about the x int, let y equals 0. Right. That's for your x-intercept. And then you will notice something. I already spoke about the function like this, or maybe the one like that, right? If now you can't, okay, all right, before I talk about this, let me finish about the x-intercepts. Notice your x-intercepts, when you have x-intercepts, that's why I will say when you have x-intercepts, which means you have 2 of them. And in grade 10, only in grade 10, the 2 intercepts are the same numbers with different signs. If it's actually 4, both sides is 4. It's 4 and 4. But the other 4 is negative, the other one is positive. If it is 6, it is 6 and 6. But the other one is negative and the other is positive. If it's 9, it's 9 and 9. With the other one being negative and the other one being positive. That's when you have the x-intercept, only in grade 10. Right. Now let's talk about this one while we are still on the x-intercept. We say there is no x-intercept here. But then if now you try to find out what are the x-intercepts and find like, it seems like it doesn't work well with this method. Now design a table method. The same table method that we did earlier, use it. You will find that like somewhere where you get to the values of x is equals to what somewhere. I mean, you know, let me check. Yeah, where you get to y equals to 0, you find that it gives you error. Leave that point and move on, because there is no value of x right there. Just because of this. Remember, y is equal to 0 on this line. That's why y is equal to 0. So, when now you press y equals to 0, it gives you error. Move on to the next value, because there is no value of x right there. So, which means you start seeing that like, okay, on the next value, all right, it changes. Now it's curving, going the other direction. So, on the table method, if this one cannot work, which means you must know once this one is not working, you use the table method and you already master. If this one is not working, then there is no x-intercepts. That is that. Now, when you have found, that is if like they are intercepts, if you have found the intercepts, x-intercept and y-intercepts, if you have found those, I mean before the table method, if you have found those, if they are there, now join. This one probably becomes a TP, like I said earlier, and then these, they are in opposite direction with the same value. Put them, dot them, and then join, TP, join, and that all the points, right? We are done. And then if this one does not have the values of x, you come table method and then use the values on the table. TP, blah 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 blah, and then you are warm and dry. That is the parabola. And then how do we actually find the equation of, this is the sketching, remember, how do we find the equation of a parabola now? The equation of a parabola, 2 forms are given, right? You are given a TP, you are given a TP and a point. A point, and then they ask you to determine the equation of a parabola. Yes, given the TP at the point, the TP is in the form of 0, maybe 0, alright, it's in the form of 0y, but let's just say it's 0, 5. Remember, now we're not sketching, we're actually determining the equation. And another point, which is 2, 3, right? Generally. Now, what do we know already? We know that the f of x is equals to x squared plus q. That's what we know. So now we can continue and say f of x here is equals to a. Oh, alright, let me start with ax squared plus, let's substitute that one, 5. Now take this point this side. 3 equals a times 2 squared plus 5. Yeah, all this is 2 squared. 4. 4a plus 5 equals 3. Take that one to be minus 5 plus 3. That is minus 2. I'm too fast. Equals 4a. Right? Minus 2 equals 4a. Divide by minus. Divide by 4. So a equals 1, negative 1 over 2. So you have the value of a, you have the value of q. That is what is important. Now you can come and say f of x equals 1 over, or negative 1 over 2 x squared plus 5. And then you underline your answer. As easy as like 1, 2, 3, R, A, E, O, O. That's how it works. So that's how it works. If you find this link and you don't understand, a short break before we go to the next way of getting the parabola, the equation of a parabola. A short break, quick. My number is 0678908546. That's my business number, 0678908546. Yes, message me there and then we'll talk business. Right, this is how we determine the equation of a parabola. But there is also another method. How about you are given 2 points, 3, 5, and 5 and 2, 3. Given just 2 points in general. Now welcome to simultaneous equations that I ran away earlier on. I ran away from simultaneous equations because there is a lot of job there, but as well, simultaneous equations, they are just very easy. I will design another lesson for simultaneous equations another day. But because now we have this, we have to do simultaneous equations. Right. We know, what do we know? F of x equals ax squared plus q. That's what we know. Apparently, we don't have what do we call that? The q, the y-intercept. We don't have it, which is practically the TP. We don't have it at the moment. We're given 2 random points, 2, just that one and that one. So what we're going to do here, we are going to take first point and say 5 equals a times 3 squared plus q. 3 squared is 9, so 9a plus q equals 5. Before we manipulate, let's come and take the next point, which is this one. We say, using that one again, we say 3 equals a times 2 squared plus q, right? So we have 4a plus q equals 3. Here we have 5. We have 9a plus q equals 5. This side we have 4a plus q equals 3. Now we can manipulate q actually. We can manipulate q. We can say 5 minus 9a or whatsoever equals q. I shifted this one to the other side. Right? This is your equation 1, 2, 3. Right? This is 1, this is 2, this is the new one, the third one. Now take this one, the newly designed equation, and put it to the second equation. So we can continue and say 3 equals 4a. Now in place of q we have this, we can say plus 5 minus 9a. That is that, right? Moving this one to the other side, leaving that one that side, you'll have 3 minus 5 equals 4 minus 9a, 4a minus 9a. What do we get? This is minus 5a, right? Is equals to 2. Divide by minus 5. So a equals 2 over 5. What a beautiful fraction. A equals 2 over 5. Now we can take this thing, plant it here or plant it where? That side, in 1. Let's plant it in a 2 because 2 has smaller values. Even if you plant it in 1, you're still going to get the same answer. We're still looking for the equation. Now we have the value of a 2 over